Hello, let's do some more calculus. So we are on daily lessons 187 and 188. It says for each of these functions given below, find both f prime of x and the integral of f prime of x. So we're kind of going f prime and then going back to f of x, and we're going to see what happens here. So in f prime of x, actually, this is really good practice. Find the derivative of f of x. Don't forget, wow, chain rule applies. Did you get it? The derivative of sine is cosine. Leave the inside alone, times 3. Okay, now in this problem, this is asking find the integral of f prime of x. So it's asking me to integrate 3 cosine of 3x. And you might say, we already know the antiderivative. We know that it's sine of 3x, but let's go through that process to get there. So if I'm taking, I'm going to take another color. If I'm integrating 3 cosine of 3x, I have to see that there's something else going on here. There's a 3 right here, and I've got a function within inside this function. So I need to be like, oh, what's happening? Did the chain rule apply? And now I need to kind of go backwards in my thinking. So I just look at what is like the main part of this function. So in this case, cosine. And I think, what's the antiderivative of cosine? The antiderivative of cosine is sine, but we still have to leave the inside alone. And then we have to think, okay, well, is there anything else I would have to do in order for this to be my derivative? Let's try it. The derivative of sine of 3x would be cosine, leave the inside alone, times the derivative of the inside. So this is it. I'm done with that part, except plus c, because this could have had a constant in the end. We know it didn't, but it could have. Okay, let's do another one. So I've got e cosine of x. Whew, gross. So if I took the derivative, this is a really good reminder of all these rules. The derivative of e to the anything is e to the anything times the derivative of the anything. So in this case, I would have e to the anything times the derivative of the anything. The derivative of cosine is negative sine of x. So what's hard is you would have an integral that was given something like this. And you would have to recognize this is just a composite function. It was something e to the anything, and I did the chain rule. So here, I'm going to focus on just the e to the anything. Think, okay, well, what if I just start out with this? E cosine of x. Would that give me this? Well, the derivative of e to the anything is e to the anything times the derivative of the anything. So, yeah, that's it. I'm here. But don't forget plus c. So this is my original function. There we go. Okay, in the next one, just a reminder of what natural log, the derivative of anything that has a natural log, or natural log of anything, is 1 over the anything times the derivative of the anything. So we would say 1 over x squared plus 3 times, and don't forget parentheses if you're writing it out like this, 2x. In this case, it wouldn't matter because it's just 2x. If you have an integral, you would have to recognize that I've got x squared plus 3 in the denominator, and I've got a 2x right here. This would be pretty tricky because you'd be like, what is this thing? And you'd have to recognize that this is all raised to the first power, and that really this is the same thing as x squared plus 3 to the negative first power. And then you'd have to be like, okay, well, what if I do this normal power rule? I add 1 to the exponent, I get 0, divide by 0. Ah, something's happening. And so you can't do it that way. You should be like, okay, what could this possibly be? If I can't add 1 to the exponent and get 0, and I know the chain rule is happening because the derivative of this inside stuff is 2x, what could I do? And you know the common phrase, when in doubt, natural log. It's not common, but that's what's happening here. So you'd have the natural log. Whenever you're doing the antiderivative, instead of parentheses, most mathematicians put absolute value here just because you can't take the natural log of the negative number, so it restricts the domain. So you'd say the natural log of, and then in this case it would just be x squared plus 3 plus c. If you wrote it with parentheses, it would not be wrong. Okay, the next one, I've got this, and I think, how do I take the derivative? Remember that f of x can be written as x squared plus 3 to the 1/2 power. So if you take the derivative, 1/2, leave the inside alone. Notice I just did this without saying it. So I took 1/2 out in front, I subtracted the exponent times 1, I left the I subtracted the exponent by 1, I left the inside alone, times the derivative of the inside. Because all of this happened, 1/2 times 2x would just be x squared plus 3 to the negative 1/2, or this could be written as x over, this 1/2 will be in the denominator, and I can rewrite it as a square root. This is also what f prime of x looks like. This can be really tricky to figure out and be like, what did I start it with here if I'm integrating? So if I saw this integral, I'm like, I thought, what could I possibly do here to get back to the original function? You would have to consider this as x squared plus 3 to the negative 1/2 power dx. This is like the main part of the function, so I'm dealing with this first. So I'd add 1 to the exponent, that'd be a positive 1/2. And then I would see, well, what about the inside? But if I just added 1 to the exponent and just left it there, and then I do a guess and check. So I am guessing this, I'm adding 1 to the exponent. I'm not even going to divide by my new exponent here because I can mess around with coefficients. You're going to learn that soon. So if I just took this and I say, okay, well, what's the derivative? 1/2. I leave the inside alone. My new exponent is negative 1/2. And then times the derivative of the inside, 2x. I should actually do this. If I were to do this down here, 1/2 x squared plus 3, negative 1/2 times 2x, same thing that's happening over here. It would, in fact, look like that. A lot of my answers are going to look like this, where this is my answer, and then down here I'm checking my work by finding the derivative to see if I get what I get on the inside. Ooh, and I almost forgot something. Whew, plus a constant. Okay, so this is pretty tough though, because all of these, this wasn't that bad because we had to f of x and then we went to f prime and then we integrated, so we had an idea of what was happening. But there's some of these that is just by pattern recognition, that you know something is going on with the chain rule. And so how can you recognize that? So if I take the derivative, and this is just a function within a bigger function. This is the chain rule. Wow. I take the derivative of the outside, so f prime. I leave the inside alone, times the derivative of the inside. Isn't it fun how none of this stuff goes away ever? You're like, yeah, so fun. If you see an integral that looks like I've got the derivative of something, and then whatever's here, this is really the main part, that I've got a function inside and its derivative on the outside of this integral still, so still all remaining in the integrand. You know something's going on where I've got, if I went backwards, the antiderivative, leaving the inside alone. But this is tricky, and I realize that you're like, I'm kind of with you right now. That's okay. Kind of with me, and it's an okay place. Shutting off the video, walking away, or throwing something on the screen, not as good. You just haven't learned this yet. Let me help. So let's do some examples with this. You just get better the more you do with this. So in these ones, you're finding each of the following by pattern recognition, meaning you're recognizing that the chain rule applied, and you're trying to guess and check, go backwards, and see if you can find the original function. In this first one, I see cosine. And so there's a 3x in there also, but I've just got this cosine to begin with. So I'm like, what could that possibly be? The antiderivative of cosine is sine. And you can't just leave that, or I'm sorry, you can't just ignore that 3x. So I'm going to treat this as sine of 3x. And then what I'm going to do is, before I do anything else here, I'm trying to find it on the marker, before I do anything else with this, like multiply by some number or divide this by 1/3, I'm just going to check my derivative and see, well, if I took the derivative right now, the derivative of sine is cosine, leave the inside alone, times the derivative of the inside. Hey, they match. Woo woo. That means we've got it, except for a plus c. This is my answer. So I guessed, but I checked to make sure that whatever was inside the integral matches here. Okay, let's do another one. In this one, I've got this integral, and I want to rewrite this as, this is 2, and it's not actually x to the third, this is 2x, and then this is x squared plus 5 to the 1/3 power. So you have to recognize, like, what is the main part of this function. You see how there's stuff on the inside here, x squared plus 5? I can see the derivative of x squared plus 5 is right here. So this is the part I want to deal with. And I want to say, okay, what's the antiderivative? Well, if I left the inside alone, and here I'm just doing the same rules as before with when we first started doing antiderivatives, where I add 1 to the exponent. So if I add 1 to the exponent, I would get 1/3 plus 3/3, which is 4/3. And then I'm just going to leave it like that and take the derivative and see what happens. So in this one, I've got 4/3. My new exponent would be 1/3. Leave the inside alone. If I compare them, then I've got x squared plus 5 to the 1/3 is the same as x squared plus 5. The cubed root, same thing. I've got a 2x here and a 2x here. And you're like, that's not good. I've got a 4/3 here. I can take a coefficient along for the ride, meaning if I take the derivative or the antiderivative, the coefficient just stays there. It's just multiplied at the very end. And so what I can do here is, this was my guess of what the function was. I can change my guess knowing that a coefficient is just taken along, like right along in the derivative, that I can say, well, I can just multiply my derivative by a coefficient in the end. To get rid of this 4/3, because that's the only thing I don't want, I'm going to multiply by 3/4. But I can't do that here unless I do that here. If I were to try again, 4/3 times 3/4 would be 1. I leave the inside alone. X squared plus 5 to the 1/3 times 2x, because that's the derivative of the inside. I did it. Add your plus c. This is the indefinite integral. The plus c makes it the indefinite part because we don't know what the c is, the constant in the end. Okay, how about, could you try this one? Okay. To do this one, I would think the main part of this is sine. The antiderivative of that is negative cosine. I'm going to leave the inside alone. I'm going to check myself. The derivative of negative cosine is sine. Leave the inside alone. Times the derivative of the inside. It matches up entirely. That means I can just put my plus c. And I'm good. Okay. If you're feeling great, keep going on and trying these, but I'm going to stop on each one so that I can explain it also. So in this one, I've got 2x plus 2 over x squared plus 2x. So I'm going to rewrite this. Anytime you have a fraction, I would rewrite the denominator. This will be 2x plus 2 times, in the denominator, x squared plus 2x to the negative first power. I can see the derivative of x squared plus 2x is 2x plus 2. So this is like the main part of this function. This is the outside of the composition of functions, whatever that is. So this part, I'm going to say, what's the antiderivative of that? Well, if I add 1 to the exponent, I would get 0. Divide by my new exponent. Ah, that's not good. As soon as you get 0 when you're adding, you divide by it, and you're like, I can't divide by 0. Something's wrong. When in doubt, natural log. And here's where you're going to be like, okay, I'm going to write it exactly like natural log of x squared plus 2x. And then I'm going to check. So now that I'm trying natural log, I'm going to say, well, what's the derivative? 1 over the anything times the derivative of the anything. And that looks exactly like I have up here in the integrin. So I can say plus c. Let's do another one like, well, no, I'll get there. I'll just go in the order in case people are trying this. Okay, try this one. What's the antiderivative of cosine? Sine. Leave the inside alone. And now we're going to try taking the derivative. So this was my guess. This is my check. I check to make sure my derivative matches. I've got cosine 3x plus 2 times the derivative of the inside, because wow, chain rule. You're like, okay, this matches up, but there's a 3 here that I don't want. How do I get rid of it? Remember, you can always multiply by a coefficient as long as whatever you do the derivative, you also carry along with the antiderivative. So I'm going to say times 1/3. Now I've got it. These take practice. In the next one, I would rewrite it. So I've got this integral of 3x times quantity x squared plus 2 to the 1/2 power. This is 2x. The derivative of this inside is 2x, and I've got a 3x out here. As long as the variable is correct, like it has the correct exponent, this has an exponent of 1 whenever I take the derivative, I'm going to just go with it for a little bit because I know I can mess around with the coefficients a little bit. So, dealing with this part of my function, I'm going to add 1 to my exponent. X squared plus 2. Add 1 to my exponent, I would get 3/2. And now that was my guess. Now I want to check. 3/2. Leave my inside alone. My new exponent would be decreased by 1, so 3/2 minus 2 over 2 would be 1 over 2. Times the derivative of the inside. The derivative of of x squared is 2x. Huh, that one turns out nicer than I thought. Because you see I've got 3x. Here's 3x. X squared plus 2. X squared plus 2. This was square root. This is raised to the 1/2. So I can end with a plus. 2 more. Try this one. The derivative of e to the anything is e to the anything. So the antiderivative of e to the anything is still going to be pretty similar to e to the anything. So there's a 5 out here, but I'm not worrying about that yet. I'm just going to say, well, you know what? The antiderivative is probably something like that. Let's try it. This was my guess. Now I'm going to check by doing the derivative. E to 3x times 3. Like, this one has a 5. This one has a 3. So I need to get rid of the 3. Oh, sorry, I can do this. Get rid of the 3. It's a 3. Divide by 3. Multiply by 5. E looks funny. So here I'm going to have 5/3 e to 3x plus c. Okay, last one. I've got 3. Ooh, sorry. I threw my phone a little bit because it's blown up and I don't know why. Okay, I've got 3x over this. So I'm going to say 3x. I'm going to rewrite separately and then rewrite this as 2x squared plus 3 to the negative 1/2 power. The derivative of the inside, this 2x squared would be 4x. I'm okay that this is 3x. Like, as long as it has an x out here, I'm good. So I'm going to take the antiderivative, which would be leaving the inside alone. My new exponent is a positive 1/2. And that's my guess. Like, that's all I've got. I took this, and this is very simplified, and I'm just going to see what happens if I take the derivative. I have 1/2. New exponent is negative 1/2. I leave the inside alone. Wow, times the derivative of the inside. So all of this together, this would be 4 times 1/2 would be 2x over this thing is going to be a square root. I'm sorry. 2x squared plus 3. So what I can see is that the difference here is this has a 2, this has a 3. So I want to get rid of the 2. So divide by 2, multiply by 3. You can try this again and make sure. This was my guess. If you want to check it again, you should definitely get the derivative that's here. Thanks so much for watching and learning. I think you're great. Let me know if you have any questions. Bye!